So am I audible, Nasim?
Yes, you are audible.
The screen is visible, right?
Yes, screen is also visible.
Fine. So I'll start. Okay, so first I'll give a quick recap of what we had discussed in the last class. Then we will move to today's lecture. Okay. So last week we were discussing about root finding, right? About different nonlinear equations and what do you mean by a root, how to interpret it graphically, all those things we were talking about. And then we saw, we just brushed on our basics where we were talking about different kinds of parameters which are available in these equations, like variables, expressions, functions. What is the difference between a linear and a non-linear equation? All those things we were talking about. Then we understood what is meant by the roots of an equation, how to interpret them graphically. Then we looked into the different numerical techniques. The two kinds of numerical techniques are the bracketing methods and the open methods. In bracketing methods, there are two kinds, bisection method and regular falsy method, which we discussed in the last class. Then we have the open methods. There are three kinds of open methods where Newton's method, secant method, and fixed point iteration. So last class we had discussed about total three methods, bisection method, regular falsy method, and the secant method, right? So today we will be talking about Newton's method. First we'll be talking about fixed point iteration, and then we'll be talking about Newton's method, and then we'll be solving some equations. The algorithm I'll first discuss, and then I'll solve some equations. So these were the about the different roots of an equation. So we basically talked about from the graph, we can find out if we can plot the any kind of equation, then the intersection of that particular curve with the x-axis is basically the roots of an equation. I described why it is intersection with the x-axis, because any equation when we are trying to solve it is basically f of x, a function which is equal to 0, right? So basically there are two functions here. One is f of x and another is y equal to 0. One is y equal to f of x and another is y equal to 0. We are basically trying to find the intersection points of these two curves. So y equal to 0 basically is the x-axis. So that is the main reason why we always find the roots using a graph. It is nothing but the intersection of that function with the x-axis. So then we learnt about the bracketing methods and the open methods. So the what is the main difference between the bracketing methods and the open methods? The main difference is that the initial guess of the roots in a bracketing methods will be given in the form of a particular range or a bracket. Whereas in open methods, there will be a single initial guess of the root. And we iterate over that using a particular iterative technique. We basically iterate over that initial guess, and we, after a few iterations, we gradually merge at the towards the root. So then we discussed about the bisection method, the graphical interpretation of the bisection method. Then I solved one equation based on the based on the bisection method. And then we moved to the secant method. We discussed about it is basically an open method where we have two initial guesses of the solution. And then I described how to find the equation of a secant, and from that how to get the iterative formula, which is highlighted here. The recording. So this is the basically the iterative formula of a secant method, and then we solved one equation based on that. Then we moved to the regular falsy method, where we found out that using the similarity of two triangles, we found out the iterative formula of a regular falsy method, or a method, or the method of false position. So first, what we will do today is, so you have any doubts with respect to last class, Nasim? Any confusions, any doubts you want to clarify?
No, nothing. No doubt is there. Concepts are clear from the last class.
Okay, okay. Regarding the assignments, any problem is there, you can tell me anytime, okay?
Okay, okay, sure.
So today's class, we will basically start with what we will discuss today. So I'll list down the topics first. So first we will be discussing about single variable fixed point iteration scheme. Then we will talk about multivariable fixed point iteration scheme. Then we'll talk about the single variable Newton-Raphson method. We have the multivariable Newton-Raphson method. So these are the four topics we will be discussing today. First, for each scheme, I'll describe the algorithm, then the graphical interpretation, how to find it graphically, and then I'll be talking about I'll solve one problem and I'll show how to do it. So first we'll go with the fixed point iteration scheme, right? So this fixed point iteration method is also known as successive substitution. So this name is clear from the algorithm. If you see the algorithm, we basically we will be given an initial solution, and based on that initial solution, we will be successively substituting in the function and we'll be finding out the values. So that's why basically it is known as also known as successive substitution. So it is basically a open method to find the solution of f of x equal to 0. So first I'll write down the algorithm, the brief steps I will write down, then I will solve the problem. So in the algorithm, what we do, so we will be basically in the problem for this fixed point iteration, we will be basically given an equation f of x equal to 0 and an initial guess to the solution. So first what we have to do, so we have to rewrite f of x equal to 0 as x equal to some function of x, as x equal to g of x. X equal to g of x, right? So this is basically known as the iteration function. This g of x is basically known as the iteration function. So here there are two functions, right? So one is y equal to x, which is function a, and another is y equal to g of x, which is function b. So basically two functions are there. So in order to find the root of the equation f of x equal to 0, if we can rewrite it in the form of this x equal to g of x, and then in the graph, if we plot these two functions, y equal to g of x and y equal to x, and then if we try to find the intersection of those two curves, so that will basically give me the solution of the equation, right? Is this point clear?
Yes, yes, it's clear.
Yeah, so basically, then we have to find the point of intersection of y equal to x and y equal to g of x. So this will basically give me the root of the original equation f of x equal to 0, because this x equal to g of x is nothing but a different version of this f of x equal to 0, right? So this process of rewriting f of x equal to 0 is known as recasting. Okay, so this process is known as recasting. So here the next step will be, this procedure usually begins with an initial guess x1 near this fixed point, that is the root. So the root here is known as the fixed point, that is the intersection of y equal to x and y equal to g of x, that is known as the fixed point, right? So how we find x2? X2 will be, so x1 we will get from the initial guess, so that we will substitute in this g of x and we will get x2. Similarly, after this we will get x3, which will be given by g of x2. So like this we will go on until we converge, right? So now the main thing here is the concept of recasting. So we will try to understand this concept of recasting. So suppose I am given with an equation f of x equal to x square minus 4x plus 1 equal to 0. So how can you tell me how can we find out x from here? So one way is we can write x square plus 1 by 4. So this is one possibility, right? What is the other possibility? Can you tell, Nasim? Any other possibility to just find out how x we can find out? Yes, Nasim, are you able to hear me?
Yes, yes, I can hear. We can
So,
like
hmm,
we can break it in two form, not break it. I think. Yeah,
yes.
we have to express it in means in form of x, like something.
Yeah, like x equal to g of x, some function of x. So x equal to that thing we have to express. So one way I told is x we can 4x we can take, and x square minus 1, x square plus 1 we can move to the other side of the equation, and then we can find out x equal to x square plus 1 by 4. So how else can we express? So can we write like this, x square equal to 4x minus 1. From this also we can write 4x minus 1 to the power half, right?
Okay, okay, understood.
So this is another way. One more way is there, like we can do it. So this 4x we can write as x square minus 3x minus x plus 1 equal to 0. From this we can write x equal to x square minus 3x plus 1. So there are unlimited number of ways by which we can do this. We can express this equation in the form of x equal to g of x, right? Is it
Means
clear?
we have to
Hmm.
yeah, yeah, I want to ask that there means there are n number of possibilities that we can write the equation, same
Yes,
equation.
yes, correct.
Okay.
Okay. So, okay, we will solve one more. This is the concept of recasting I explained you, right? So one more equation we can have like this. Suppose I have one exponential equation. I will take f of x equal to x minus 1/3 e to the power x. And it is given that the initial guess of the solution is x of 1 is 1.25. So this you have to solve using the fixed point iteration technique, right? So first we have to do the recasting thing, right? So here we can write x minus e to the power x by 3 equals to 0. From this we can find out x equal to 1/3 e to the power. This is one way, right? I'm naming this as a, right? One more way we can do it is x minus e to the power x by 3 equal to 0. So we can write it as x equal to 2x minus e to the power x by 3. So these are the there can be many other possibilities, but here I'm just listing out two possibilities. Okay, so we will try to solve using both these recasting forms and we will see whether the root is converging or diverging. Then we'll try to find a conclusion from that. Okay, is the principle clear,
Just a
right?
minute. A second equation, I think something is missing.
Right?
2 to the power minus x. I think the sign, there will be some sign changes.
No, it's x equal to 2x minus e power x by 3. So if you bring 2x this side, it is the same equation.
Okay, okay, okay.
Here minus is there. So if we use the first form, that is form A, first we will try to solve using that. Okay. So what is it? X equal to 1/3 e to the power x, right? So how can so x of 1 is given as 1.25. So x of 2 will be 1 by 3 e to the power x of 1. So 1 by 3 e to the power 1.25. So if you substitute that, you will get around 1.163. Okay.
Okay, understood.
So now this is the first step, second step rather. So third will be 1/3 e to the power x of 2. So it will be 1/3 e to the power 1.163. So it is around 1.066. So like this, if you continue up to say 20 iterations, this I have basically done in the MATLAB and I have seen. So it is basically coming around 0.619. So if you find out the root of this equation by any programming technique, you can find that there are two roots of this equation, right? So it is basically one is 0.619, another is 1.512. These are the two roots of the equation, actual roots of the equation. These are the two roots. So you can see here, if I take this form of the function, that is x equal to e to the power x by 3 using this recasting function, we are gradually converging to one of the roots, which is 0.619. Okay, so likewise, if we take the second function, that is x equal to 2x minus e to the power x by 3. So from here, basically, if we find out x of, and for this, it is given x of 1 is 1.75. Okay. So x of 2 will be basically 2 into 1.75 minus e to the power 1.75 by 3. So if we find it out, it will be around is 1.58. Similarly, x of 3, if you find out, it will be second. Okay, 2 into 1.58 minus e to the power 1.58 by 3 is around 1.541. 1.54 will write. So like this, if one more iteration we will do. So you can see it is gradually converging. And if you do after say 20 or 30 iteration, it will basically converge to 1.51, which is the other root of the equation. Is it clear?
Yes, I understood.
Okay. So one more example I'll show you where it is not converging. Okay. So suppose if I use the first form, right? So it was x equal to e to the power x by 3. And x of 1, suppose it is given instead of 1.25, I'm taking 1.75. So if you do in this, you will see that after 4 or 5 iterations, it is okay. I'll do it. So like this, if you do after 5 or 6 iterations, you will see that it is diverging. So if you see here, the roots are diverging. Here it was converging, right? So from this, we can conclude one thing, that this root convergence will depend on two main factors. What are the two factors? Can you tell, Nasim?
First is the expressing the equation in
Yes,
multiple
correct.
forms.
Yes, that is the choice of g of x. That is the recasting function, right? That is one. Another one,
And another one is the initial guess.
yeah, the initial guess, whatever is given. So that these two factors will basically determine your convergence, whether your thing is going to converge or whether it is going to, whether the roots are going to diverge. Okay. So I'll show this using one graphical approach. Just bear with me for 1 minute. So if we try to find out, one is y equal to e power x by 3, right? So it is something like this. Something like this. And another function is y equal to x, right? So this is, I'll draw it using a straight line. So if we try to draw y equal to x here, So this is suppose y equal to x. Okay. So this is your y equal to x, and this is y equal to e to the power x by 3. So these are the two roots, right? This is one root. This is one root. So basically, first we will take. So here we have shown here that if we take 1.25 as the initial guess, and in this functional form, then it is converging. Whereas if we take 1.75 as the initial guess, then it is diverging. Okay. So suppose I am taking my initial guess here, which is around here. Okay, 1.25. 1.25. I'm naming this point as A, which is 1.25 comma 0. So basically what we were doing here. So we are basically finding out in the algorithm what is being told. So we have a function g of x, and we are substituting in that function continuously. Successively, we are just substituting. So basically what we are doing here, so at the first point, which is y equal to x equal to 1.25, here basically we will draw a vertical line and find out where it is intersecting my g of x curve. So this point it is intersecting, right? Let me name this point as B. So what is x of 2 here? X of 2 is the value of this function, right?
Yes, yes.
Yes, value of this function at this point. So what is the y-intercept of this? Means what is the y coordinate of this point? If we means extend this line and we name this point as, say, this point as C and this point as D. So basically, so this is my x of 2. This E point, the x-intercept, the x coordinate of this point is the this thing, your E point. That is the second value of x in the iteration. So is this point clear to you? How I am getting this x of 2?
Yes, yes, I understood.
Okay. So now the same thing we will again do, right? So what we will do, E we got, again at this point we will find out what is the functional value, which is f here, right? So then again we will find out the y coordinate of this point. Here let us say f, this is g. Then we will again find out what is the x-intercept of this, h, which is x of 3. So you just see here, if I draw the arrow how we were doing. So first we went upwards, then we went in this direction, right? Towards D. Then we came back in this direction. Then we went here. Again we went here. Again this side. Again we came back here. Again use. So here if you see this arrow from C to F, to say this is your, this point is I am telling. C F I, we are gradually moving, right? So this is my x here now. So gradually here, if I'll just, so like this, we are gradually moving towards the root. So here is my actual root, right?
Yes,
So we are
yes.
moving towards the actual root. Is this concept clear?
Yes, yes. Means we are slowly, step by step, we are converging to the root.
Yeah, we are slowly converging towards the actual root. So now if I find out, say, if I take an initial guess around say 1.75, right? So that was not converging according to our calculations. So suppose 1.75 will be a point some here. Okay. Suppose this is my one a dash I am taking, which is 1.75. So maybe the scale of the graph is not correct. So if you see here 1.75, if we follow the same procedure at 1.75, the value is this value, right? Functional value. Then we will move here. Then we will again move to our y-axis, right? Here. So gradually, if you see here, we will move in the upward direction and we will be diverging from the root. So
Okay,
here
that is why we
yeah,
are getting large.
I'll just show it once again here in the this thing. Suppose your graph is like this, and this is your y equal to this thing. Okay. So if you take some point here, so what will happen? It will move in this direction gradually. If you move in this direction, you are moving away from the root, right? Your root is here, this point and this point. So you are gradually moving away from the root. So that's why it is diverging. So we have proved it graphically also. Is it clear?
Yes, yes, it is clear.
Okay. Okay. Just a second. Okay. So this is about the single fixed point, single variable fixed point iteration. So I hope you can solve any kind of problems using this. It is so you have understood the graphical approach. Once you have understood that, everything will be much more clearer to you. Okay. So now we will move to multivariable fixed point iteration. Okay. And one more thing I forgot to mention here. Suppose if you take a point a double dash here. So then also you would have converged. If you just do the same procedure here, if you draw a perpendicular line, so you would have seen that like this, you would have converged towards the root. You zoom here. So here you would have converged towards the root. Only if the point is beyond this intersection, this root, then only your thing is, it is going beyond, it is diverging. Okay.
Okay, okay, okay.
You can just try with some value, some lower value, just initial value, and you can check using, you can check your calculations and you will see that you will also converge. Only if your initial value is greater than the highest root, that is 1.51 here, then only if your initial value is around 2 or 1.75, anything like that, it will diverge from the root. You will not move towards the root. So the choice of the initial guess is very important in any numerical technique, especially in our this fixed point iteration technique. The choice of the initial value is very important. Okay.
Okay, okay.
So now we will move to the multivariable fixed point iteration, right? So the algorithm is almost same. Just we will, instead of a single variable x which we were solving here, here you will have multivariable. That is, you will have a vector. So suppose you have a set of equations which is given by fi of x equal to 0. That is, one equation is f1 of x is x, y, x is 0, f2 of y is 0, like that. So I'm representing that as a set of equations. So it is basically multivariable, right? So my solution vector, that is x bar, we will represent here. It is given by x1, x2, and x. And this fi of x or f bar of x, that is a set of equations which are given. So if there are three variables, there will be three equations, right? One is f1 of x bar, one is f2 of x bar, another is f3. So here I'll solve one example here and we will try to understand. So the logic is almost it's exactly the same. So suppose one equation is there, f1 of y bar is given by 4 minus 8y2 plus 4y3 minus 2y2 cube equal to 0. And another equation is f2 of y bar equal to 1 minus 4y2 plus 3y3 plus y3 square. So what is your y bar here? It is basically two variables, right? y2 and y3. And your f of y, f bar of y is basically f1 of y bar and f2 of y. And here also two initial values will be given, right? So y bar of 0 is given as one is 0 point, sorry, 0 0.5 and 0 point. So this will be given to you and you will be asked to find the final solution of y2 and y3, that is y bar. Is the problem clear to you?
Yes, it is clear.
Fine. So we'll try to solve for one or two iterations and then we can stop it. So first iteration. So what we were doing in fixed point iteration. So from the first equation, you have to find out y2. That is the first variable. From the second equation, you have to find out y3. If there is one more equation, the other variable you have to find out. So basically, from the first equation, you have to express y2 as g of y2 and y3. So first, the most obvious one I will do recasting. So if we take y2, 8y2, so it is basically 4y3 minus 2y2 cube plus 4 by 8, right? So this is y2. So from this, if we try to substitute y2 of 1, so it is basically 4y3 of 0, 2y2 cube, y2 0 cube plus 4 by 8. So y3 0 is half, right? So it is 2 minus 2 into half cubed means 2 into 1 by 8, or it is 1 second close to it. 2 plus 2 minus 1 by 8 plus 4 by 8. So it is basically 6 minus 1 by 4 by 8. So it is 6, 24, 23. It's 23 by 32. I think. 6 minus
0.71.
it is around. We'll take till 3 places, okay? 4 places we'll take.
0.71.
0.7188. So, okay, this is from the first equation, right? And from the second equation, we'll try to find out y3. So the second equation is basically 1 minus 4y2, 3y3 plus y3 square equal to 0. So 3y3 will be equal to 1 minus 4y2, y3 square, or y3 will be this. So this square divided by 3. So therefore y3 at the first step will be 1 second, I'm doing it wrong. I think here y2, 8y2, if we take here, it will be same. Here 3y3, it should be different, right? Minus should be there. Minus 1. Is it correct, the equation? Can you check once? y3, 3y3, if it goes up. Okay, fine. So it is minus 1 plus 4y2 0 minus y3 0 square by 3. So it is minus 1 plus 4 into 0.5 is 2. Y3 0 is 4. So it is 1 3 by 4. It is 1 minus 2 minus 1, 1 3 by 4. It is 0.25, I think. Is it? It's 0.25, right?
Just a minute checking.
So y bar at the first step is 0.7188 and it is 0.2503. This is
It
at the
is
end of
minus
the
2.5. In the
yes.
first answer is minus 0.25.
Is it minus?
No, sorry. Okay. It's 0.25, 0.25.
0.25, no?
Yes,
Ah, it is 0.25. Okay, this is at the first step, right? So now
yes.
if we go to the one more iteration we will do. Okay. So okay. So your y2 of 2, right? Now we have to find out y2 of 2 is equal to, so the equation is same. It is 4y3 of 1 plus 2y2 of 1 whole cube minus, sorry, 1 second, what we did here, 4y3 minus 2y2 cube plus 4, right? 4y3 plus 4 by 8, is it correct? 4 by 8. So if we substitute here, what is y3 of 1? We got 0.25, right? So it is 1, 2, y2, 1, 2 into 0.7188 whole cube. So it is 0.7428 plus 8 plus 1 plus 4 minus 0.5321. Is it correct? Calculation, can you check once? 4131.
Yes, it is correct.
Correct, right? So next we will find out y3 of 2, which is 4y2 of 1 minus y3 of 1 whole square minus 1 by 3. 4y2 of 1, okay. So 4 into 0.7188 minus 0.25 square 1 by 3 is around 0.604. So your y at the end of the second iteration, it is 0.5321 and 0.604. So like this, you have to continue. One more I'll do, because so until the difference between these two, right? Y2 of 1 is 0.7188 and here it is 0.53. So at least one decimal place should match, otherwise we cannot stop. So in the third step, again y2 of 3 or 2, y2 of 2. So y bar of 2. Okay. 2 we have found out, 3 we have to find out now. Y2 of 3 equal to 4y3 minus 2y2 plus 4y3 minus 2y2 of cube plus 4y8. 4y3 of 3. Sorry, this is 16042 minus 2.5321 whole cube y3 of 3 equals to 4y2 minus y3 square minus 1 minus y3 square minus 1 by 3. 4 into 0.6042 minus 4 into 0.51 minus y3 square is around 0.254. So like this, we have to continue. Okay. So until
Yeah,
we,
yeah.
so basically in your assignment problems, you'll be asked the values up to the first or the second or third iteration maximum. So if you want to solve it, you have to write a computer program for that, and then iteratively you have to solve this. So this
Okay.
is all about the multivariable fixed point iteration. So for this, we cannot describe this graphical interpretation because these equations will basically be in the 3D, right? Because two variables are there and it will be a plane. And intersection of the planes, it will be difficult to show in the plane paper. So I'm
Yes, yes, it
avoiding
is
that
very.
part.
Yes, yes.
You can imagine it in the same way as I have described for the single variable fixed point methods. Here also same thing you can imagine and you can do it.
Okay.
This is about the multivariable fixed point iteration. So now, one second. Just 5 minutes, 10 minutes break I will take and I will come back. Okay.
Okay, sure, sure.
Okay, so I'll start. You're here, Nasim?
Yeah, you can start.
Hello, are you here, Nasim?
Hello.
Yeah, you're here, right?
Hello. Yes, you can start.
Okay. Okay, so now we have completed the fixed point iteration technique. We will move to Newton's method. That is, or Newton-Raphson method, you can call. So Newton-Raphson method is basically an open method, right? Like the fixed point method, it is an open method. So first I'll describe it graphically and then I'll derive the iterative formula. Then I'll solve two problems I'll solve and then we will move to the next topic. So what we do here basically is you will plot f of x first. So suppose I have a graph like this. Suppose I have a graph like this and I want to find out this. These are the two roots, right? These are the two roots. Oh, sorry, not this one. Second. Hmm. So there is one root. So this is this is the root, right? So I'll start with an initial guess will be given because it is an open method. One initial guess will be given to me, right? So suppose this is my initial guess, which is x0. Okay. So what we will do here basically is first we'll draw a vertical line to this and we will try to find out the tangent to this point. So here, if you find the tangent, will look something like this, right? It is not perfect, I know. Something like this. So then basically we extend this tangent. Mm, So suppose this is my tangent and this is the x-intercept. 1 second. It is 1 second. I will draw it up. Okay, so this is my initial guess, which is x0. We find the value of y corresponding to that value. At this point, we try to draw a tangent, which is like this. Then we extend this. So this is my x of 2. That is the second value of x of 1. Again, we repeat the same process. We try to find a tangent here. We extend this tangent. This is x3. Now if I zoom, you can see again the same thing we will try to do here. So this is the point. Here again we will draw a tangent. This is a tangent, right? So here we will try to extend. This will be my x of 4. So this is my x4. And my root is here, right? So you can see from x0 to x4, we are gradually moving towards the root. Is it clear? The geometrical interpretation, how we are trying to approach towards the root.
Yes, yes, it is clear.
Okay, fine. So now we'll try to find out the iterative formula also from this. So this is my y, this is my x, right? So here, if you try to find out the equation of this tangent, so basically we need to find out x1 or x2 or x3 like that, right? So here, if I try to find out, so what are these 2 points? So this point is basically x0 and f of x0. And one second, this is basically x1 and 0, right? So we try to find out this one. So it is basically y minus, we are considering it to pass through this point x0 and f of x0, right? So it is basically y minus f of x0 will be equal to m. Now what is the slope of this line basically? So the slope of this tangent, we can basically tell it to be the derivative of this function at this point, at this black point, right? So any function, if you want to find the slope at that particular point, suppose you have a random function like this. If you want to find the slope of this function at this point, what you will do? You will draw a tangent to the curve at this point, and the slope of the tangent will give you the slope of the curve at that point. What is the slope of the curve at that point? It is the derivative of the function at that point. So basically the slope
Oh,
here, is it clear?
yes, yes, understood.
Okay. So it is basically f dash of x0, right? M x minus what is x1? It is x0. So this is your equation of the tangent. So now we want to find out x1, right? So at x1, value of y is 0, correct? So we'll substitute in this equation y equal to 0 minus f of x0 equal to f dash of x0, and x is basically x1, right? So from this, if we find out x of 1, it is basically x of 0 minus f of x0 by, sorry, by f dash of x0. So this is the basically the formula for Newton-Raphson which is given in the textbooks. So this is how the formula or the iterative equation for this Newton-Raphson comes into picture. So from this, so I'll write this equation once again. It is basically x of 1 is equal to the previous value x0 minus functional value at the previous by the derivative of the function. So from this we can generalize, right? X at I plus 1th step will be the value of x at ith step, f of xi by f dashed of x of I. Is it clear how this is coming?
Yes, yes, understood.
Understood, right? So first we'll try to solve a problem using the Newton-Raphson technique. So question is, So here f of x is x to the power 2.5 minus 12x to the power 1.5. So you have to find the solution of this equation using Newton-Raphson, where initial guess is x0 is given as 0. So first step we will do. First, for Newton-Raphson method, first you find the derivative of the function. So it is 2.5 x to the power 1.5, 18 x to the power 0.5 minus 20. Right? Okay.
Yes,
So
yes.
what is x1 now? It is x0. This is the first step. Okay. Minus f of x0 by f dash of x0. If we substitute this, x0 is 0 minus, if you substitute 0 in f of x, it will be basically how much? 120 by, here if you substitute, it is 0, 0 minus 20. So x1 is 6, right?
Yes, yes.
Now, if you substitute x of 2, it is basically x1 minus f of x1 by f dash of x of 1. So if you substitute this 6 minus, this will come out as, I have done the calculation, it will come out as minus 88.18 by minus 27.35. So this will come around 2.78. So still difference is there, 6 and 2.78. So we have to do few more iterations. So this will be x2. I'll do the calculation. It's not done. 2.78 minus f of 0.2.78. 2.78 to the power 2. 0.78 to the power 2.5 minus 20.78. So it is coming around 21.66. And f of f dash takes is 2.5, 2.78 to the power 1.5. You can also do the calculation. Value. So it is coming around 3.34. So just check the calculation once. Is it correct or not?
Yeah, it is correct.
Okay. So one more we will do. I think it will converge in this step. Minus 3.34. We have to substitute 3.34.5. 3.34. 3.5. 0.339 by 2.5 into 3.34 to the power 1.5 minus 15. So it is 3.34 minus 0.339, 7.6. So like this, it has almost converged. We can see here. So if we take 2 places of decimal, this will be 3.343 places of decimal. So this will be 3.349. So almost it has converged. One more iteration, if you do, it will converge to the third step also. To the third
Okay.
decimal, to the digit after the third decimal place also. So one more thing I want to tell here. So is it clear, right? How to solve
Yes,
this Newton-Raphson method?
yes, it is clear.
Okay. So one more thing will tell you here. So see, from this equation, this x of I plus 1 is equal to x of I minus f of xi by f dash xi, right? So from this graph, you can see as we move closer to the root, first was x of 0. Yes, you're telling anything?
No, no, no. You can continue.
Okay. So here we are x of 0. Then we move to x of 1. Then we move to, this should be x2. And here we move to x3. So gradually you can see as we approach towards the root, the value of the function at that particular point is turning out to be 0. Right? So x of 0, there was some value of the function. So it was here. Now, when it is x of 1, you can see it has reduced. Further, when it is x of 2, it is further reduced. And so gradually, here when it is x of 3, the value of the function at this point is this one. So that is very less. So from this equation, you can see as we approach towards the root, this f dash of xi is turning out to be 0. So if this is turning out to be 0, this whole term, the second term is 0, right? So that's why x of I plus 1 and x of I will be almost equal. That is, as you move closer to the root, this x2, x3, x4, these are much closer. And we stop the iteration when the relative error, that is the difference between this x of I and x of I plus 1 is very small, of the order of 10 to the power minus 3 or minus 4. So that is what I am trying to tell here, that from this equation also, you can appreciate this fact that the convergence criteria, that is the difference between the value of x or the value of the root at the previous step and the present step, will be very less. That is the difference between the x of I and x of I plus 1 till it turns negligible, we have to carry out the iteration. So from this we can also understand this. So from this example also you can see here, gradually this f of xi, that is this value. See here it was some minus 88, right? Then it reduced to 21. Then it reduced to 0.339. One or two more iterations if you do, it will reduce to even further less. So is this, try to understand from this perspective also, because otherwise you will just end up memorizing these formulas and you will not appreciate the beauty of this technique.
Yeah, yeah, understood. Yeah,
It's clear, right?
yeah, yeah. Graphically, it is clear.
Okay.
Slowly, we are converging.
Yeah. Okay. So one more problem we will do in this Newton-Raphson. It is basically an application-oriented problem. So the famous van der Waals equation we know, right? We have studied in our physics classes. So it is basically, it gives a relation between P and V, right? That is pressure and volume. So
Pressure,
this is the
pressure, volume, and temperature.
pressure, volume, and temperature. So from the ideal gas equation, we basically have PV equals to nRT. So van der Waals basically somewhat changed it and modified it and introduced two more constants, which are A and B, and then he proposed a new relation which is given by this equation, right? P plus A by V square multiplied by V minus B equals to RT. So
It is
here,
for one. It is for 1 mole of gas.
yeah, it is for 1 mole of gas. Okay, so here we don't need to understand the physics of that. So for this problem here, it is given for ammonia gas, we have to basically solve this equation. So A is given 0.4252, B is given 3.373, 10 to the minus 5. Universal gas constant is R 8.314. for a pressure of 10 to the power 6 Pascal and temperature of 300 Kelvin, you have to find volume of the gas V, given V of 0 is 0.0. So V of 0 is given to you 0.01. So this first we will solve using fixed point iteration method. Okay. So using fixed point iteration method, we'll try to solve this equation. So what we did in fixed point iteration, just recall, we expressed that x equal to g of x. Second. Hello, Preeti. Hello.
Hello, sir. I want to ask that I want to ask that about the paper pattern. What will be the paper pattern, or fully objective type or subjective type?
Please, I'm taking a class now. You wait till the end of the class. I'll tell you.
Okay, sir. Okay.
Okay. So I'm discussing about fixed point iteration technique. So if you want to attend, you can attend the class.
Yes.
Okay. So in the fixed point iteration technique, basically, we are trying to we have to express this x is in terms of g of x. So basically here it is not x, rather it is v that we are trying to find out. So basically here we have to express it in terms of v equals to g of v, right? So here if we find out, we can the equation is p plus a by v square into v minus b equals to RT. So v minus b we can write RT by p plus a by v square. So v we can write as p plus RT by p plus a by v. So this is my recasting form. That is v equals to g of v, right? So now from this, first we'll substitute the known values and then we'll simplify the equation. So b is basically 3.373 e minus 5. Sorry, it is into minus 5. R is 8.314 into 300 by 10 to the power 6 plus how much is a 0.4252. So 8.314 into 300 is basically 2494. So it is. So this is my equation, right? So if we find out V of 1, it is 3.373 into 10 to the power minus 5, 2494.2. So V of 0 square, right? So V of 0 is 0.01. So if you do this calculation, you will basically find out it is 2.517 into 10 to the power minus 3. So we first iteration, we have found out V of 1. Similarly, if we do the second iteration, that is V of 2, so it will be basically 3.373 into 10 to the power minus 5 plus 2494.2 10 to the power 6 plus 0.4252 by how much was V of 1? 2.517 10 to the minus 3. 2.517 10 to the power minus 3 whole square. So if you calculate it, it will come around 2.371 into 10 to the power minus 3. Similarly, V of 3, if you calculate, it will be 3.373 into 10 to the power minus 5 and 4.2 10 to the power 6 by 2.371 into 10 to the power minus 3 whole square, around 2.35. So here you can see it is almost same, the two values up to the first decimal place, to the digit up to the first decimal place. So this was an if you try to solve it analytically, this equation you cannot solve it because it involves second order equation. You have to do that quadratic equation. It will be more complicated. So using this fixed point iteration technique, you can easily solve it. And within two or three iterations, you have got the value of v also. But only disadvantage of this type of method is the initial guess that for any practical problem when you want to solve for your when you try to solve anything, initial guess you have to just provide it correctly. Then this algorithm can easily solve your any kind of equations. Is it clear, Nasim and Preeti?
Yeah, it is clear. I wanted to
Yes.
ask, that means it is not suitable for real life problems because we don't have any initial guess in real life problems.
Okay, so I'll tell that. So basically, initial guess, you can get it based on your understanding of the problem. Suppose you are trying to, uh, you are from which background? Means BTech, you are from
I am
which
from
branch?
I'm not from BTech. I'm from MSc chemistry.
Okay, MSc chemistry.
Yes, yes.
Okay, so if you try to think of this any kind of system, chemistry, I'm not familiar, I cannot tell you anything. Any system, when you are trying to solve any equation, if you are trying to describe it, then obviously initial value getting that is a problem. But based on some experiments, some results, you can sometimes you can obtain an idea fairly. It may not be exactly correct. You can get an initial solution, and based on that, you can try. Obviously, that might not be accurate always, but yes, this is one of the disadvantages of this kind of techniques.
Yes.
Okay.
Priti, is it clear or is it
Yes,
fine?
sir. Yes, sir. This is clear.
So, okay. So this is about the Newton-Raphson technique, and then I described one problem on van der Waals equation, this fixed point method. So now we will move to the last topic of today, which is multivariable Newton-Raphson method. Okay. So So if you want to, if you have set of equations and you want to solve the Newton-Raphson method, which has more than one variable. So till now we had seen basically an equation with a single variable, right? So here I will describe you how to solve it for multiple variable equations. So suppose you have, so you have one second. The equation is, first equation is 0.08 minus 0.2x1. This is one. And another equation is x1 to the power 2.4. So these are the two equations given, and the two variables are x1 and x2. The initial guess is given to you 1 and 1. That is x1 of 0 is 1 and x2 of 0 is also 1. So now for just recall what I had described you for the single variable case. For single variable case, what was x of I plus 1? It was basically xi minus f of xi by f dash xi, right? So for multivariable case, this equation, so these are all vectors. So here in multivariable case, this is a vector x. There is a column vector xi minus Jacobian inverse of xi into f of xi. So this single variable equation, if you just rewrite it, you can write like this, right? F dash xi inverse. So if you see these two equations, the single variable and the multivariable equation, it is almost same, except for this f dash xi, we are having a Jacobian matrix here, which is J inverse xi. So what is this Jacobian matrix? Suppose this equation I am naming it as f1 of x comma y, x1 comma x2. 1 second. I'll just for this easiness, I'll change the variables. Suppose this is x, and this is y. X and y I will make, otherwise it will be confusing. Y square. This is y. Just I've changed the name of the variables to x and y. Okay. So okay. So here basically we'll try to see what is Jacobian matrix. So any one of you have heard about Jacobian matrix?
Yes, sir. J del u by del x, del u by partial derivatives matrix.
Uh, no, Jacobian. Have you heard of Jacobian? That is different. What you're talking about, Nasib.
Okay.
So Jacobian matrix is basically dou f by dou x. Then you have dou f by dou y, dou g by dou x, and dou g by. This is second order Jacobian matrix. So this first equation is my f, and this is my g of x comma y. So I'll write these equations once again. So f of x comma y is 0.08 minus 0.2x x to the power 1.5 plus 0.2 y square, and g of x comma y is x to the power 2.4 0.1 y. So now from these two equations, can you find out dou f by dou x?
It's a point
Can you
two,
tell? Yes,
0.2 minus 1.5 x to the power 0.5.
yes. That is it, right?
Yes.
And dou f by dou y.
It is 0.4 y.
And dou g by dou x is 2
2.4
point x to the power 1.4. That's it. And dou g by dou y.
minus 0.1 plus 0.4 y.
So now you can find out Jacobian matrix at x. So presently we are at which step? We are at the 0th step, right? So Jacobian of x of 0. So it is dou f by dou x 0. That is dou f by dou x at x0.
Yeah.
At x0, comma y0. Dou f by dou y at x0, comma y0. This is dou g by dou x at x0, comma y0. Dou g by dou y at x0. So can you substitute and tell me what are the values here? So x0, y0 are 1 and 1, right? So here it
Minus
will
0.
be, yes.
Minus 0.2 first value.
Uh, Sorry, it will be minus 1.7, right? Here 1.5, x to the power 0.5 is also there, and x is 1.
Okay.
So it is minus 1.7. This is 0.4. This is 2.4. And this is 0.3. So from this, we have to find out the inverse of this, J inverse of X of Z. So if you find out the inverse of this by finding adjoint and all, you have to find out. I'm not doing that calculation. So it is minus 0.204, 0.272, 1.633, 1.156. Now you have the inverse of the Jacobian matrix. So now you can find the iterative value. What will be x of 2? X of 1 minus J inverse. Sorry. F of x of. So x0 is basically 1 and 1, right? 1, 1. Minus J inverse is basically, what is J inverse? I just find out minus 0.204, 0.272, 1.633, 1.156. Then you have f of x0. What is f of x0? This I forgot to mention. So here you have one more thing, right? This f of xi. So in capital, I will write it. What is f of xi? So it is this set of two equations. This is f1 of xi and f2 of xi. So basically, you have to substitute the value of x in these two equations. So if you substitute these two values of x here, I'll see it is 0.08 minus 0.2 minus 1 plus 0.2. It is minus 0.92, and this is 1 minus 0.1 plus 0.1. So now if you calculate this matrix calculation, if you do, you will get 0.283. This is after the first step. Similarly, so this is your x of 2 now. Again, you have to find out your j for the, this is done for the first step. So now once you go to the second step, you have to again find out, you have your j in terms of the functional values, right? So here you have in terms of the functional values, this dou f dou x dou g by dou x, dou f by dou y, and dou g by dou y. So here now in place of x and y, you substitute these values, this 0.283 and 0.812, and find out what is j of x of 1. Once you get j of x of 1, again you find out j inverse x of 1. Then you use this iterative formula and find out what is x of. So this is basically a very hectic process to be carried out manually. So you can write a MATLAB code. Next class I will show you how to write the MATLAB code, and I will show you the convergence also. So this is all about this thing. Is it clear to you?
Yes.
I
Yes,
wanted to ask, can you means slide means previous slide, go to previous slide,
yes.
previous again.
Yes.
Yeah, below like f of xi, I couldn't understand. Could you explain again?
Yeah. So basically f of xi is the value of the function at the point of xi. So it is basically a column vector. So here you have two equations given to you, right? What is, one is f of x, another is g of x.
G of
So
x.
basically here it is basically f of xi, and this is g of
Oh,
xi.
okay, okay.
So if you are at the first step, it will be f of x1 and g of x1. So basically x1 and y1 you substitute in these two functions which are given to you, and you will get a column vector. Just that is what is f of xi.
Okay, okay. I understood.
Any other doubts?
No, sir.
Any other doubts? Any questions you want to ask?
Yes, sir, I want to ask about the paper pattern.
Yes, paper pattern means the final exam pattern you are asking, right?
Yes, sir. Yes, sir. Final exam pattern.
So that will be objective only.
fill in the blanks or objective, both?
That I am not sure. I have to talk with professor once and I'll let you know. As far as I know, the NPTEL exam, all it will be of objective pattern only.
Okay.
Like as you are having in your assignments, similar kind of thing will be given to you in the exam.
Assignments are in fill in the blanks type, sir.
Okay. Okay, I'll get back to you. I think it will be similar to the assignments only. Still, I'll confirm and I'll get back to you.
Okay, sir. Thank you.
Okay. Any other questions, clarifications anyone wants?
No, sir.
Okay,
I
then
want to
fine.
give
Yes.
one question. This multivariable Newton Raphson, it is means very hectic process it is. So if in
Yes.
exam comes, so just for one iteration it will be given.
Maximum one iteration it will be asked. You can check the
Okay.
assignment problems also. It will be maximum one iterations they will ask you. Because
Okay.
finding the inverse of a 2 x 2 matrix, that is itself a hectic process. So again, you have to find the inverse for every step and then you have to calculate the iterate over that value and find out.
Okay.
One or maximum they can ask 2 steps. They shouldn't ask for 2 steps. Maximum they will ask for 1 step only.
Okay.
Is it clear? Then okay then.
Okay, sir. Thank you, sir.
Okay, then I'll stop for today. We'll
Yes.
meet again in the okay. So next class actually I am having some issue. Saturday I will not take. I think it is communicated to you by email. I'll be taking the next class on this Tuesday, that is 27th from 7 to 9. Okay.
Okay, sir.
Okay.
27th Saturday Tuesday from 7 p.m. to 9 p.m. I'll take the class.
Okay, sir. Thank you, sir.
Okay.
Okay. Okay, fine.
Okay.
Thank you. Bye.
Thank you.